Hey guys, I'm going to show you a short demonstration that all the students who are able to come to class have seen. So this is for the students that are at home. Now this is something you've probably seen before, but some people think it's a magic trick and some people think it's not. So what I've got here is a plate, ordinary plate, fork and spoon, and a beaker of water, and it's on a tablecloth. And what this is a demonstration of the principle of inertia. So I'm going to do the tablecloth trick. So here we are. So we can just pull it here, grab the tablecloth, and if we do it like we mean it, the objects for the most point stay in place when I pull the tablecloth out. Now I'm going to do that again so you can see it again. You can watch it one more time. What I have is it's actually a satin pillowcase, so it's smooth. It's not a lot of friction. I also have it set so that there is a seam on one side and no seam on the other side. And I put the tablecloth down so that just the fold, there's no seam here, is on this side of the plates. And finally, when I pull it out very suddenly and abruptly, not a gradual pull, but a sudden jerk. So here we go, 1, 2, 3, there it is. A couple things to think about here. The plate barely moves, and the beaker of water barely moves, but the fork and the spoon move a lot. And the question is, why does it happen this way? And the answer is, pause it if you want to think about it a little bit first, but the answer is the plate has a lot of inertia. It tends to stay in one place because that's what objects with inertia do. So when I pull the tablecloth out, it doesn't provide very much friction with the plate because the bottom of the plate is fairly smooth. And what force there is doesn't last for very long because I jerk the tablecloth out very quickly. So there's not a lot of force acting on the plate, and it doesn't act for very long, so the plate doesn't move very much. Same thing with the beaker of water. It has a lot of inertia. There's a lot of mass here, and the bottom of the beaker is smooth, so it doesn't move much because the force is small and doesn't last very long. Now, the fork and the spoon, they bounce around a lot because they have much less inertia, so it doesn't take much force to make them move. It doesn't take much to accelerate them, so they jangle around quite a bit. Now, the last thing is, why do I make sure I don't put the bumpy seam behind the plate? And I think you can see this just with your common sense. If I had the seam here, then when I pull the tablecloth out, that seam might catch the edge of the plate, and then it's grabbing. The force goes way up because we're not just talking about a little bit of smooth friction. We're talking about actually grabbing hold of it and pulling it along. Okay, so that's the principle that we're talking about here. Objects don't move very much because they have inertia if there's not much force acting on them. Now, the lab you're going to do today involves sliding pennies across a table, and it's the same idea. I want you to think about the forces which are acting on the stack of pennies and the forces which are acting on the individual penny at the bottom, which is knocked out from underneath the stack. Okay, that should be enough to get you going, and good luck with your lab.